Let me quickly introduce today's presenters. We have Ramon Malero. He is a deployment engineer here at Mirantis. He works directly with customers. He does installs and upgrades and tests, and this is his bailiwick. He used to be a Linux platform engineer at IPsoft, and he's been in various data center and sysadmin roles at Data Foundry. And along with Ramon, we have Bruce Matthews. He is a senior solutions architect at Mirantis. So he has a good look at sort of the big picture of all this. I know he has been working very hard on these service mesh projects as well. He's been a senior solutions architect in the computer industry for more than 40 years, which is, I think, about as long as Star Wars has been around, Bruce?
Yeah, but actually the big reason that you put me on this call is because I was voted most likely to look like our mascot, the bear with glasses.
There you go. It's true. It's true. He's much less likely to maul you, though, I think, than the actual bear. So that's always a good thing. Bruce has worked, besides the Mirantis, he's been at HP and Oracle and Sun. And I just realized you and I share a couple of companies there. I was never at HP, but I did work for Oracle and Sun also.
There you go.
Anyway. So, moving right along, let's talk here. Let's do a little bit of housekeeping. If you have been to one of these webinars before, and even if you haven't, you will see on the right-hand side of your screen a pane, well, a window that has different panes in it, one of which enables you to ask questions. Go ahead and put your questions in there, and we will save them for the end and answer them after the demo. All right, so just a little bit of an agenda. We're going to give you a quick overview of Istio and service meshes, and then we'll talk about the sample application that we'll be demoing over this multi-cluster architecture. And then Ramon has put together a bunch of demo exercises to demonstrate various concepts and tasks. And then we will do the Q&A. So Ramon, are you in and presenting, and are you ready to go?
I'm ready to go here.
All right. Can we, Michelle, are we seeing his screen? I don't know what we're seeing because I'm only seeing my screen. Yes, yeah, we are seeing. Okay, so let's move this on, and I am going to turn it over to Bruce and Ramon, who are going to carry it forward from here, and I will jump back in later on. So take it away, Bruce and Ramon.
Thanks, Nick. Here we go.
So yeah, so today we're going to be going over Istio and multi-cluster applications and how that can, be used for your organization to enable the ease of use of, multi-cluster applications and the control plane of Istio, basically. We'll be, as mentioned, we'll be going over just a little bit of architecture of Istio and a little bit of Kubernetes and microservices in general. And then we'll go into a demo and any questions you have about the demo.
Yeah, so let's go about getting some context here, and so what are the elements that we need to think about in terms of these multi-cloud applications, my friend?
So typically you have, Kubernetes is going to be a single cluster. You can manually manage your multi-cluster kind of situation with Kubernetes, but Istio has a lot of extra features and security features that make that much easier for your deployment and ease of use for your developers. Istio itself is basically just a control plane that you add an additional set of containers and policies that get added to your Kubernetes cluster that adds another control plane on top of Kubernetes, basically, and it enables a couple of other sets of features that enable multi-cluster operations to be easier. In our example, we have 2 clusters, and we're deploying Istio 1.1, which enables us to have a control plane in each individual environment. You can also have a single control plane in just one cluster and have it controlled through the Istio gateway and other aspects. But in this example that we're doing today, we have 2 control planes, one in each cluster. So the networking between clusters is basically controlled through Istio and its concept of the service entry. The service entry is basically going to be a way for you to define your library of information of, hey, this guy exists in this cluster, this exists in that cluster, and that enables you to communicate through an Istio gateway. You can see that here we basically have 2 copies of the Hello World sample container, and whenever we have a local connection that requests it, here in this example we have 2 containers, version 1 over here on the left and version 2 on the right remote cluster. When the connection comes to a local cluster, the connection comes straight to the pod's node port, and you can see that the pod IP here is a local 10 dot address. And when it gets round robin to V2, it knows, so based on that service entry, that the V2 is going to exist in the remote cluster. So for in that instance, it knows that it needs to connect through the gateway IP and not through the node port. You can see that V2 has a 192 address, and that 192 address is actually the gateway IP of the remote cluster. And then your Istio control plane inside of your remote cluster will handle the connection to the internal node port, and then the connection comes back.
So when you start spreading out an application service like this, it would seem to have some security implications focused around it. Does service meshing and Istio apply to that need?
Sure. So Istio does cover that aspect for you basically automatically by having basically every service you have, the communication internally will be automatically be with TLS. There's basically a concept called the sidecar that is a proxy that intercepts all communication and transparently upgrades it to HTTPS for you. Even though your backend communicates on both sides with HTTP, that's how you configured it. Istio will basically intercept and upgrade that traffic for you. Other built-in security features are going to be ACLs, basically typical things that happen on your layer 3 networking layer, where you have a network or firewall or something like that. The extra proxy that you have in between your services enables you to do more layer 7 ACLs and traffic interception. And it also has built-in role-based access control into Istio itself, so you can set up HTTP, basic auth, with JSON web tokens. It has several supported role-based access control methods.
So, I know that some of the service meshes out there are based on like using a library, and some are used for node agents that are used to define this. But I've heard, I guess, that Istio is based on sidecarring. Could you go into that a little bit?
The main way that Istio is able to transparently, do all these things for you is that it adds what's called a sidecar. And a sidecar is basically a extra container that gets added to every single one of your services in your deployments that transparently intercepts and based on predefined rule sets can forward the traffic to the appropriate services or externally out to the world. This is able to be added either transparently by adding it on a namespace basis, or you can add it just cluster wide, and you can enable it. It's called a sidecar injection. It enables it to just automatically see that you're adding a new deployment or service, and it will automatically add the sidecar for you. Or you can explicitly add it to your YAMLs and not have it injected. If you want to have some services be Istio service and some not, you can manually take the Istio CTL binary and you can upgrade basically upgrade your basic templates that you have for your deployments and add sidecars to it that way.
Terrific, thanks. Well, that actually gives us most of the basics we needed to preface this demonstration we're going to be doing. How about taking a look at an example application?
Sure. So our example application is basically a microservices reference application called SockShop. It's you might have heard of this. It's a pretty well-known reference application that uses a lot of containers to basically handle every aspect in the microservices fashion. It moves away from the typical monolith architecture that's I'm sure everybody knows. It's, you have a server with a database server and an application server and maybe a web server in front that handles that all on a single server, or maybe multiple servers split out depending on your stateful, stateless application. And the SockShop basically is a microservices architecture type application that separates out all your services into individual containers and pods to facilitate development, maintenance, troubleshooting for any kind of situation. It's a much more flexible system than the old monolith architecture. We see a lot of enterprises and stuff like that moving over from monolith architectures to microservices now.
Cool. So I guess we're really focused on the service meshing of this thing. Can you go into a little more detail about what a service mesh is?
Sure. A service mesh is basically going to be a configurable infrastructure layer for your applications. And what that means is that it's basically a system that manages the library of information that your application needs. You can have your front ends on one cluster and your databases on another cluster. You could have specialized database server in your data center and a web server on Amazon Web Services or Google Cloud or somewhere else. It's basically a way for you to have basically either a public, private, or hybrid cloud configuration where you have all aspects of the application that can communicate with each other. It provides a lot more capabilities to developers that they would typically have to handle manually and individually for each application. And in Istio's instance, the security is
Cool.
The upgradable TLS is an example. If you didn't have that and you had all your applications to be TLS, your developers would have to handle that individually for each application, each communication that happens. In the case of Istio, it handles that transparently for you.
Terrific. Well, I think you have some examples to show us of this, so I'm excited to see them.
Yeah, sure. So our demo is basically going to be a couple of different parts. First thing is we're just going to go show the example SockShop and how to apply it to both clusters. We'll do we'll view the clusters directly without a load balancer just after the deployment. We'll put a load balancer between the clusters, and we'll do first a 50-50 load balance, and then we'll switch it quickly over to an 80-20 balance. And then we'll do a simulated load to the Istio clusters to basically simulate how we can use Istio to reduce latency and to use horizontal pod scaling using Istio. And then the last example would be a circuit breaker where we simulate a failure in one cluster, catastrophic failure in one cluster, and it automatically handles that. The sidecars and the Envoy proxies handle that automatically for us. So let's get to the demo actually itself. So just to kind of give a background on how this application was, we basically took the SockShop reference application and we enabled in our namespace. So you can see here in our namespace that we enabled the Istio injection flag for that namespace. So we create the SockShop namespace in Kubernetes. We label that namespace to add the Istio injection flag and we enable it. So what that means is that we're basically taking these stock deployment YAML files from SockShop off the reference app, and we're not basically doing anything except 2 security changes that we had to make. Those were two small modifications that we'll discuss later towards the end of the demo. But other than that, there was no modifications done to SockShop, and we're basically installing it from scratch into Istio with injection enabled. So here we have Kubernetes. I have the work that I've done pre-work was basically install Kubernetes. I have 2 Kubernetes clusters, and I have the application set up, and I have a script that will basically install both, install SockShop into both clusters for us. I'll make this a little bit bigger for everybody. So now it's going into cluster 1 and basically creating all the pods, all the deployments and services needed for SockShop. And you can see here that we've created the namespace, and this is the label for the Istio injection. And after this is just the typical pods that are being created for the SockShop. And so the 2 aspects that are unique to Istio in this SockShop is basically the gateway that we created to allow Istio to route into the SockShop, and then the virtual service that's basically the definition for the built-in Istio load balancer. And now we're going into the second cluster and deploying the same exact thing into the second cluster.
Right. So that gateway is really where all the magic happens, right? Because it's redirected through that specific point. So you can do tapping at that point and
Exactly.
a lot of other things.
Exactly. In a typical Kubernetes setup, you would create a load balance port, and that would open you up to expose your Kubernetes cluster. But in this case, the load balancer is created by Istio. You have a existing load balancer that is created by Istio, and that is basically used for all your services and is used as the Istio gateway for the communication that helps you transparently communicate with the other clusters. Okay, and I think at this point we can look at go ahead and look at cluster 1 since it's already been deployed. And we should see a SockShop come up here. And here we go. We got SockShop up in cluster 1. This is a SockShop. It's basically a fake SockShop where everything is handled individually. The catalog is a microservice. The shopping cart is a microservice. The login system is a microservice. So that's basically, instead of being split out into one giant application that handles everything, each individual spot is split out. So in case you're having trouble with your shopping cart, to go to your shopping cart microservices to look at them and investigate there further.
Yeah, and I love the socks.
Yeah, the socks are pretty good. They got some expensive socks. Holy socks. Believe that. So looks like we got cluster 2 as well. So let's look at cluster 2. It should be an exact replica of cluster 1. And then we have cluster 2 ready to go. So we basically have 2 identical versions of SockShop without any kind of load balancing in the middle. And so that's basically our first demo. We were able to deploy a SockShop to using Istio and gateways. Next slide. So now we already basically viewed clusters 1 and 2 directly. We saw that we were able to get a sock shop correctly on both of them. So next step is that we're going to be enabling a load balancer in between clusters 1 and 2, and that will use Istio's built-in load balancer to add a 50-50 load balance between both clusters that we just created. And also Istio manages the built-in names as well for the typical virtual host that you have with Apache or Nginx, where you have a virtual host name that you use, and it handles that for you as well. So we'll see that in cluster 1, we can no longer access cluster 1 because its name was removed and it was changed to a load balance port. So now we're getting a 404 from Istio. And if we go over to the load balance version of it, we have a different DNS name here. And here we'll get a 50-50 load balance between both applications. And we can see that here I can go ahead and log in. This is just a placeholder user login, and we have a successful login. And now those two clusters are going to easily share the cookies and all the necessary things for the application to correctly load balance between the two. So right now this is just a simple round robin load balance. We could go ahead and look at the catalog, add something to the cart, and that's the load balanced version of Istio here.
Wow, that really looked easy to make it highly available for one thing, and to share the load so that you could handle a greater capacity, right?
Sure. Yeah, it could. So next step is that we're going to basically take that same load balancer and we're going to do an 80-20 split between those two. Okay, so now we should have an 80-20 split enabled between the two environments. And as you can see, we still have our cookies and our user logged in. We can see our shopping cart. And there, perfect. So we have an 80-20 split here now enabled.
Yeah, so that really helps you to shape the traffic when you've got more users localized to one area versus another, or those kind of things. That looks pretty handy.
It's definitely handy. You can use it for any kind of hybrid cloud, private, public cloud mix that you have, depending on what your application needs. And so the next demo is basically we're going to simulate a load to pods in Istio and scale. We're basically using here the built-in Prometheus container that comes with Istio. Istio deploys a Prometheus container that the Envoy pods that get created basically send transaction information. And you can see that Istio is keeping a request total for pods. So we can give it the name of the workload and the namespace that workload exists in, and we'll basically get a request total, because since those pods are intercepting all our traffic, the pods are basically able to give us a real-time view without any kind of intervention from our part. We can basically get built-in monitoring for our HTTP traffic through Istio. And what we're using that traffic for in this example demo is that we're taking those requests total and we're using that as a metric in our horizontal pod scaling system here. So yeah, let's go ahead and start that example.
Yeah, so we're kind of simulating Black Friday, eh?
Basically a Friday. Everybody gets off of work on Black Friday and go straight to the internet to buy your products.
There you go.
Okay, so we'll go ahead and just give it just an initial small load to kind of get a baseline of traffic. Here we're simulating 100 concurrent users for 5 seconds, just to kind of give it an initial load, and we'll get just kind of like a baseline for what our application behaves and the speeds that we'll expect from the application. So here we can see our slowest transaction was about 0.2 seconds, and we had about 2,000 requests per second as a baseline. So now I just need to enable the view for our get a view to the Prometheus instance. Okay, and here we could see that Istio, remember, this is just a basic application. We did no configuration for monitoring. This is basically a view into Istio's metrics, HTTP metrics, since that Envoy proxy is supplying these metrics here. We can see our individual pod hit a peak of about 453 requests per second here. So now we can look at our pods and see just kind of like the initial that we have two containers in our test pods. So this would actually normally be one. If you were deploying this straight to Kubernetes, we would only have 1 out of 1. But since the Istio sidecar is being added to this environment, we have 2 out of 2 in this environment, and the Istio sidecar is added in there. So now we'll add our horizontal scaler to this environment, to the pod info service. And let's just take an initial look at the pods. So we can see that we have a 10 max of pods. We have a minimum pod of 1. And currently we don't have any transactions coming in, so that's unknown. So now we'll go ahead and simulate a higher load. In this case, we're going to take 30 seconds, and we're going to take 30 seconds of hits, and we're going to simulate 200 concurrent users. Our users just went up by 100, and we have a longer time period where they're being basically using the traffic. And during this time, we can actually look at over here at Prometheus, and we can see our traffic start to come up. And just on the metric that we use here, you can see that the metric is the total requests divided by the count of pods, basically. And so this traffic graph is not total requests, but the rate of requests smoothed out per pod. And then here we can see our traffic continues to build.
Boy, that's a lot of traffic.
A lot of quick traffic. So now we've smoothed out, and our test here is basically done. So now we can see that our latency actually went up slightly since we only had 1 pod. We went from 0.2 seconds to our slowest response to now 0.4 seconds. We had about the same amount of requests per second, about 2,000 requests per second, with a total of 60,000 responses in 30 seconds. And so if we take a look at our pods and our horizontal scaler, we should shortly see that we have a increase in our number of pods, and we can see that our pod info got scaled up. We can see that we already have 2 extras running, and we have 1 more pending. Take a look one more time. We should see our replica also go up. And there we go. And our pod scaler also took advantage of that, and now we have 4. So let's go ahead and do another similar test. We're going to simulate 200 concurrent users over 30 seconds again. If you take a look at Prometheus, we'll see that since we stopped that test, our rate of requests dropped down back to 0. And since now we have more pods, and this is a smooth graph based on pod count, this time we're actually not going to see our per pod traffic amount go as high as previously. You can already see that our first initial jump was 437 on our first attempt, and now we're at 163. So those pods are evenly distributing that traffic. Okay, and the test should be done now. So you can see that from our previous tests, we were at about 0.4 seconds. We've dropped our latency, our highest latency from 0.4 to 0.34, and the majority of our transactions being under 0.17. We also were able to take a higher amount of about 50% more requests per second automatically with the Istio and Kubernetes autopod scaling. And over 30 seconds, we were able to handle 90,000 responses with only 200s coming back. So that basically shows the pod scaling traffic capabilities that Istio provides, the metrics that Istio provides for any kind of scaling that you do. And this is all built in. This was nothing that we configured for this pod. You saw we added the pod, this testing pods, and Istio was able to automatically monitor, and we were able to use that monitoring to scale up or down based on that.
Right. So, and no administrator had to take their time to monitor it and manage it and everything else. It was just taken care of for them, so they can focus on providing services to their application developers as opposed to managing clusters. So I guess this next one is sort of asking what happens if something goes wrong.
Sure. Yeah. So in this circuit breaker example, we're basically going to simulate a catastrophic failure. We're basically going to remove the second cluster out of the mix, and we're going to see how Istio is able to manage that and how it's able to control the situation. Okay, so we've basically deleted the entire cluster 2, and let's just go ahead and try, already logging in. You can see that we're logged in. Our shopping cart is still successfully working. We can navigate around our web page perfectly fine. All our individual items are working perfectly, and we can see our namespace has now been deleted. So our entire application in cluster 2 is now gone, and Envoy Proxy was able to basically transparently transfer the traffic over. It sees that the other side of the traffic is done. And remember, we left this on an 80-20 split. So now this is basically 100% split now between cluster 1. And yeah, that's a successful application. And so when we try to refresh cluster 2, we'll see that it's basically not accessible anymore. It's totally dead. We're not getting any response. Cluster 1 is not going to respond directly because of the host name here, but Istio basically provides us a 404 saying, hey, I don't recognize that name, since we're using our load balanced entry point here, which works perfectly fine. And yeah, that's the circuit breaker. So two quick things that I kind of mentioned earlier were the 2 patches that were needed to get Sock Shop working. They were basically security-related issues that were brought on by Istio. The Sock Shop uses a RabbitMQ and a MySQL backends, like a lot of typical applications. And the reason that the RabbitMQ wasn't working is because during the initialization of RabbitMQ, it has to connect to its admin ports that are local admin ports. But since the sidecar was intercepting all of that TCP traffic, even local connections, the admin port wasn't able to be reached, so that it was basically failing on startup. And to fix that, we had to specifically define the ports in the RabbitMQ service in the sock shop application. It basically was just extra security presented by Istio, and we had to specify the ports so that Istio would allow those connections to come back, even locally. And that presents a large, very good use case because, for example, if you have a compromised microservice application, they're not able, even if you have like an application that has a public port and an admin port, for example, which is typical, if a hacker is able to take over your container, if that admin port is blocked out locally and it's only used for other applications, even if they're local on that container, they're not able to reach that port and do anything malicious. The second small patch that we had to do was related to MySQL. MySQL was coming up okay, but when the catalog container was trying to reach its database, the MySQL client was presented issues because it was getting the traffic was being upgraded automatically, and that was presenting some problems with the default configuration of Istio. We were able to still keep the TLS for the MySQL connection. The typical thing for MySQL connections is you have TLS problems. You either configure MySQL correctly to have TLS, or you just disable TLS. In this case, we were able to keep the upgraded TLS traffic and simply just use the strict mode for MySQL. Well, not specific for MySQL, but the strict mode on Istio for the MySQL connections. So there were big application changes that we had to make to the reference application. They were relatively easy to find. Once the fixes were there, SockShop will, forever work in our Istio environment without any intervention from our developers or from anybody involved with the development.
Yeah, I guess technology is really boring if there aren't any bugs to fix, huh?
Yep, exactly.
All right. Well,
yeah, that was pretty much my place. Go ahead, Nick.
No, I was just gonna thank you for going through the demo there, and point out that we now are up to the Q&A. So if you have not put in your questions yet, go ahead and do that now. There's a ton of questions here, so I don't know if we'll get to all of them, but we will do the best that we can to go ahead and get as many of them answered as possible. So one that's easy. I actually have the answer to this. Will there be a GitHub with all this code? Ramon, is that ready yet? I know we talked about doing that.
Yeah, it's basically already available on the internet.
Okay.
You can put the address here in the follow-up. But yeah, it's already basically available on GitHub. It's currently using Google Cloud Platform as the backends for both clusters, so you can go ahead and try it out.
So we'll make sure that you get that information as a follow-up, as you say. All right. So, Bruce.
Yes, sir.
Let us start with you. What type of service mesh architecture does Istio employ?
I've always found it really difficult to say that word, so I started saying it as shmesh. It's a whole lot easier. But the service mesh architecture for Istio happens to be this sidecar approach, as Ramon was explaining earlier. There's basically three different types. When they first started, it was a library-oriented one, and then they came up with a node agent version of it. And then they eventually have come across this idea of injecting sidecars. So it falls into the sidecar category.
Okay. I want to, before I forget, we are going to get into the rest of the questions. Ramon, if you could advance the slides, we do have one more thing that I wanted to make sure that we did let you all know. We are hiring. So if this is of interest to you, then Mirantis would be a great place for you to come and work. So the information is here. You can just head over to mirantis.com/careers and apply and get all the information that you need. And obviously we're all here, so we like it. All right, so moving on to more questions. Let us see here. Let's see, we have a bunch of people asking how do we get the scripts, which we answered already. Okay, so what benefit does circuit breaker patterning in Istio provide? I don't know which one of you wants to take that. Bruce, if you want to grab it, or while Ramon looks at the rest of these questions and lets me know which ones he wants me to ask next, that would probably be good.
Okay. So as Ramon had provided the circuit breaker capability of eliminating traffic to one branch of the possible routes that the network traffic could take to be resolved, it sort of formulates what to deal from a self-healing standpoint to the next hop, the next place that pattern should go. And you can do that as infinitely wide across the realm as you want. So you can integrate the auto scaling with the self-healing and say, if these branches go down to a certain number, spin up more of them and recognize traffic going to the additional ones, eliminating the bad ones and things of that nature. It's really quite a handy feature for application developers who don't want to spend a whole lot of time figuring out what to do to health check their environment.
So, Ramon, are you using Kubernetes HPA to perform scale out? Not sure if you're using custom metrics coming from Istio for doing that.
Yes, so we did use the built-in Kubernetes horizontal pod scaler. The Istio itself doesn't have doesn't separate out the pod scaling. That is just built in with Kubernetes. We did use Istio metrics that come from the sidecars for measuring that traffic. And we have an example there basically that shows that we create the pod and we add the metrics delivery mechanism basically in Istio that enables the horizontal pod scaler to use as a plugin the values that come from Istio for the horizontal pod scaling.
So let me ask a stupid question. So is it safe to say that Istio doesn't actually do the scaling? It simply routes the traffic among the resources that Kubernetes has created to enable the scaling.
Exactly. Yeah. Istio doesn't replace the built-in Kubernetes pod scaling. It would be kind of be like a duplication of effort, really. For this example, we basically just use the metrics coming from those sidecars to use that.
Okay, that makes more sense. Okay, can you share the YAML files for checking how HPA is working? So I mean,
Sure, yeah.
it might be a good idea to just kind of look at them now if you have them handy. If you can share them, otherwise, we'll get them as part
of. Sure,
yeah.
It'll be there in the script in the repository that'll be on GitHub as well.
Okay. All right. Did you originally use Istio 1.0 to set this up? And if so, do you need to make changes to the app to upgrade to 1.1?
So when I first started this project, I did originally start with 1.0, but during that process, the first release candidate for 1.1 came out, so I quickly switched over. But the differences between 1.0 and 1.1 aren't very great in terms of the applications that you would have deployed and how it interacts. There might have been some small changes, not that I had to make specifically when I moved over for this specific application, but I do know there were some small differences made in the service entries, and 1.1 brought the native ability for the multi-cluster and for service entries between basically the multi-master. Previously in 1.1, you were only able to have one control plane and have a Istio gateway on both, but only one control plane. So with 1.1, it brought what we called, at least what I called the multi-master deployment, where it enables you to have two control planes, one in each cluster, controlling their own individual Istio gateway.
Aha. Okay. Let's see here. What else have we got?
On question number 15, we might need a little more background. The question says, but with fixes you've mentioned to work with Istio, I think what they're trying to ask is if there were bug fixes needed to work with Istio, other than the two, security related. I wouldn't really call them bug fixes, more like security implementations, kind of getting in the way. But we didn't really have to fix any code. It was a simple deployment change in the deployment YAMLs for Kubernetes, and that enabled the deployment of the SockShop app.
Okay. So how does Istio itself remain highly available in two or more clusters? Let's say running in a public cloud and another on premises.
So so currently, I believe each individual cluster is not currently connected. I believe this is work that is being implemented for 1.2 of Istio, where there's gonna be more inter-cluster connectivity. Right now, basically each control plane, unless you use the single control plane method, currently each control plane is kind of independent to each other. You might have noticed during the running of some of the exercises, we had to switch contexts back and forth between each individual cluster. So as far as I know, currently the intercommunication between two different Istio control planes is currently separate, but that I know is work that is being planned for the 1.2 release for Istio, where there's going to be more communication and interoperability between control planes and individual clusters.
Okay. Does the MySQL deployment for the SockShop share across the clusters? Meaning, is this one MySQL deployment or multiple?
For this specific exercise, I didn't take the extra step of connecting the MySQLs between the two individual clusters. It seems the application SockShop itself seems to work fine with just your cookies and splitting the load balance between the two, and presenting an application basic
example anyway. But
it's just an example. Yeah, but yeah, you could definitely in a production application. Of course, I take the extra step to make sure that those MySQL clusters are connected and they're definitely replicating between the two, and that you have more high availability in your cluster as well. But as mentioned, this was just an example for the webinar.
Okay. All right. Well, we have. Oh wait. Let's see. I was going to say we've run out of time, but I think we probably have time for one more. You demonstrated one balancer using Istio, so it was running on each cluster, or is a Docker container separate, running it independent of cluster 1 and 2? I'm hoping you can parse that sentence.
So sure, I can answer that. So the load balancer, so whenever you create an Istio control plane in a cluster, it's going to use whatever environment you're using. In this case, we're using Google Cloud Platform. So it's going to use that service definition that is built into Kubernetes and Google Cloud Platform that enables the creation of the load balancer. So basically at the moment that you create a Istio control plane, that control plane will bring up a load balancer that belongs to Istio. And those gateways and virtual services that we mentioned earlier are basically how you're going to control that load balancer. So that load balancer in this specific case, for this example, wasn't a separate container in our environment. It was just the load balancer provided by Google Cloud Platform that we have nothing to do with. We do not configure it. We don't touch it. We just configure it through Istio. But in a more hard, I guess a more bare metal kind of setup, that would be, you know, depending on however you have your service definition for Kubernetes as to what your load balancer would be.
Okay, all right. Well, we are out of time, so I want to thank everyone who joined us today, and thank you for your patience at the beginning while we ironed out the gremlins. So it just remains for me to thank Ramon Malero and Bruce Basil Matthews for joining us here as our presenters today. And as always, our super producer, Michelle Yakura, in the back end, without whom we could never pull this off. And I am Nick Chase, and you are you. And thank you all for joining us here today. And we hope to see you next time.
Thanks, everybody.
Thank you. Bye-bye.